All right, we're going to get started here. So welcome back to the afternoon session of day one of the inaugural Canadian and Cold Regions Rail Research Conference 2021. Our next keynote speaker is Dr. Éric Baril, Vice President of Transportation and Manufacturing acting at the National Research Council of Canada. Éric earned a Bachelor of Engineering in Material Sciences and a PhD in Metallurgy from Polytechnique Montréal, specializing in microstructural characterization of materials, anti-corrosion coatings, and steel processing. He is a graduate of the Institute on Governance Executive Leadership Program. As a research associate at the Center for Characterization and Microscopy of Materials at Polytechnique Montréal, Éric acquired extensive experience in advanced material characterization techniques. He then concentrated his work on zinc powders, zinc coatings on steel and magnesium alloys. As a senior scientist with the Zinc Product and Application Development Program, and also with the engineering team of the Magnesium Products Development Division at Noranda Technology Center in Pointe-Claire, Quebec, Canada. He joined the NRC's Industrial Materials Institute in 2004 as a research scientist. He later held the position of team leader and eventual program leader of the Vehicle Propulsion Technologies program, leading R&D activities in powder forming for titanium, steel, composites, as well as advanced materials for electric motors, lithium batteries, and hydrogen fuel cells for transport electrification. He has co-authored over 70 scientific publications, 2 patents, and given more than 100 presentations at conferences. Éric has played a key role in the development of new magnesium alloy for automotive industry, material and processes for electric motors, manufacturing, and titanium foam for medical device applications. These R&D outcomes are enabling the NRC to offer leading-edge technologies to numerous clients and partners. He has chaired and played instrumental roles in several leading conferences and symposia. Éric acted as co-chair of Electric Mobility Canada Technical Program Committee for several of their annual conferences. He is also chairing the Technico-Economic Evaluation Committee of Innové Consortium in Quebec. Please join me in welcoming Dr. Baril, whose presentation is titled The NRC's Role in Supporting Railway Research and Development in Canada.
Yeah, thank you, Kevin. Bonjour à tous. Mon nom est Éric Baril, and I'm the VP of Transportation and Manufacturing. And today I would like to give you kind of a glimpse of what NRC is doing in his everyday life to support the railway research and development in Canada. And that involvement started since the very beginning of NRC, close to 100 years ago, leading the way on the development of steam locomotive. So in just need to switch focus here. So I'll give you briefly NRC at a glance, some of the global and Canadian transportation trend, who is the automotive and surface transportation, some of our program and field of expertise, including facilities and laboratories, and going through some success story. It will be kind of blended all together, but hopefully you'll get a very good view of what is NRC and how we can work together in the railway research sector. So who is the NRC? So NRC is the largest research and development organization within the federal government. We have over 100 years of experience in various segments of the economy. We are operating across the country in each provinces with 2 types of offices and facilities through our IRAP program that I'll cover in a minute, and also through our research facilities across the provinces. What we do, basically we have 3 main mandates written into the NRC Act. Basically, advancing scientific and technical knowledge, support government policy and objective, and support business innovation. And we deliver that in 2 ways. One is through a national network of researchers and facilities performing research and technical services with partners. The other one is to deliver national funding program for small and medium enterprise through our Industrial Research Assistance Program. And overall, what we are, how many are we? So we are 2,151 scientists, engineer technicians, and 255 IRAP industrial technology advisors. And like I said, we're distributed across the country in 179 buildings on 22 sites. And every year we are delivering projects for more than 1,500 R&D collaboration, and we are helping 8,000 SMEs across the country. We're annually publishing more than 1,000 publications. We're filing more than 200 patents, and we have a total revenue and external funding sources to the level of $193 million. Our main role is related to connecting and convening. So we are organized as a neutral connector and convener internationally and within Canada and within the innovation systems. And basically, we're using our facility to do our in-house expertise as a platform for R&D for SMEs, university, and other organizations. And this is how we operate our projects. We are gathering people together around very specific missions, and we are providing some of our expertise and facility access to advanced technology, de-risk technology, and deploy technology within the various markets where we are operating. We are providing Canadian SME with access to establish an outstanding international network and building supply chain and value chain across the world with Canadian SMEs. And often we'll be co-locating research and equipment with university partners through collaboration centers to accelerate research outcomes. The way we are distributed, we're directly linked to the Ministry of Innovation, Science and Economic Development through our president. And we are distributed in various structures, but the main structure that we have to keep in mind for research delivery is our divisions, which are the blue box that you see at the bottom. And we have several divisions that are hosting 14 research centers across, and those 14 research centers are across the economic activities of the country. So going from advanced electronic and photonics, digital technologies, metrology, nanotechnology, astronomy, medical device, human health and therapeutics, energy, mine and environment, aerospace, and automotive and surface transportation, to name a few. And we also have the Industrial Research Aid Assistance Program that have office across the country and also host an international office. Where we are situating ourselves into the innovation ecosystem in the country. So basically, you see here how we view the world right now around economic benefit and societal benefit. From discovery and exploration to problem solving. And you see the various players into this field. You see universities, you see industry, you see public sector, and you see NRC. And mainly, NRC is around incremental innovation for benefit, economic benefit and problem solving. So it's really oriented towards missions and delivering on very specific technology advances. And now I'll give you way more detail about that on the way we are delivering on the automotive and surface transportation segment. And how we decide on actions and mission is really based on what we're seeing as trends globally, nationally, and also through consultation with our key stakeholders, clients, and SME partners. And what we saw over the last couple of years on the rail transportation side, some of the global trend is obviously connectivity and digitalization are number 2 trend to 2030. We're seeing also automotive cybersecurity that grows year after year because of the coming of 5G and other technologies that will enable more sharing of data, more valuation of data. We're seeing more and more decarbonization strategies to shift away rail from the diesel propulsion to new electrification and hydrogen propulsion systems. While it's very advanced in Asia and Europe, North America's system are remaining largely non-electrified. We saw also COVID impacting the rail freight sector globally, but long-term freight is expected to see a promising increase in the coming years. And in terms of ridership, obviously rail transportation has saw a reduction, a massive reduction due to COVID, but a number that is expected to rebound. Another important aspect is the connection between transportation system and mode, and this is coming through signaling, AI maintenance and prediction, and IoT communication that have disrupted the global rail technology and global rail sector. On the Canadian side, what we've been noticing is that Canadian city have projects worth close to $19 billion in subways and light rail transportation in the procurement or construction phase. You see that in Montreal, Toronto, Ottawa, Vancouver, so Calgary. You see this almost everywhere across the country right now. And there's projects under construction in several cities. During this year, third quarter, VRL recorded 86% drop in passenger revenue, as well as a decrease of 82% of ridership compared to the same quarter last year. And this is mainly due to COVID. Canadian rail company recognized the disruptive digital and clean technology. So Canadian Pacific's hydrogen locomotive program, where we'll see a development of a North American first hydrogen powered line haul freight locomotive, and Canadian National has invested heavily in predictive maintenance and IoT advancement. When we look at energy and greenhouse gas, we're right in the middle of the COP conference, and we're hearing a lot of announcement around that segment. And what we see, obviously, in those global trends on energy efficient vehicle, there's a lot on the enabling technologies, such weight reductions, that continue to be a key driver for R&D vehicles. And also the recycling of end-of-life vehicle will be part of the a critical component of the deployment of the next generation of lightweight and fuel-efficient vehicles. Battery recycling is a very good example where Canadian enterprises are more and more active. Also along the key mineral initiative and really building the value chain around the electrification of the automotive industry, which will impact the other sector of transportation in the coming years. So the Canadian presence in lightweight space is strong, with renewed interest globally with several technologies like composites and aluminum. Over the last year, we went through stakeholder consultation to work on the alignment with Transport Canada Transportation 2030 strategic plan, looking to support the development on evidence-based standard and policy, support technology development, demonstration, and evaluation, in-service of monitoring, lead the development of Canadian-focused maintenance and safety guideline on best practices, better warning system on level crossing, technology development for short line, winter and seasonal challenges. So that's what we've been hearing through those consultations, and through those global trends, Canadian trends and stakeholder consultation. We really wanted to develop a mission statement, a vision statement for the Automotive and Surface Transportation Research Center that answer and respond to the need of the industry and look at the development, the identification, the development and the application of science and technology that will ensure revolution, constant revolution of the Canadian landscape of transportation and manufacturing. And really, the objective is to keep Canada competitive and more competitive through innovation on mobility and manufacturing excellence. And really, it's with our people at the National Research Council and the development of our network that we're providing the leading edge research technology and engineering services to develop those technologies. And how we do it? Basically, we have an integrated approach where we were looking at the science, our expertise to lead innovation. And we are doing it with various mechanisms, one of which is our program. We have several programs, one of which is a supercluster, advanced manufacturing supercluster program that include grant and contribution to support and develop the manufacturing industry for transportation equipment in Canada. We have 5 R&D programs looking at the transportation systems and the advanced manufacturing. One way to deliver the advancement, and I'll present that to you in a minute, is we're running what we call industrial R&D groups. We have 9 of those that are really oriented the mission toward very specific outcomes. And we are aggregating clusters of company around those subjects and advancing the technology with them and for them. We are developing with those type of activities, local, national, and international collaboration. We have currently 1 collaboration center with the University of Manitoba called the Canadian Centre for Advanced Digital Manufacturing. And our research center, so Automotive and Surface Transportation Research Center, has specialized facilities across 5 sites. 1 in Quebec, Saguenay, Quebec, focusing on aluminum. 1 in Boucherville, Quebec, focusing on material for transportation, namely battery material, composites for structural components, coating for corrosion resistance and abrasion resistance, and other application on the material side, and also powder metallurgy for 3D additive manufacturing and other type of application related to electric motors. We have a facility in London, Ontario, focusing on advanced manufacturing, and a facility in Manitoba that will be yet to open on advanced manufacturing as well. But the core facilities that we would like to bring and discuss today is our facility in Leicester Road, where we have our group of specialists on transportation system and on the rail systems. We're working with 200 R&D clients and partners across the year, and we have 20 plus academic collaborations. Annually, we're disclosing 10 IP invention that lead often to patenting. So we have last year we did 20 patent application, and we're releasing, publishing 50 publications on average per year. And overall, we are 291 scientists, engineers, and technicians. So to give you a little bit more detail about how we deliver some of our activities, I'll just start with quickly with advanced manufacturing, and we'll go closer into down into our funnel towards the rail sector. But in the advanced manufacturing for transportation equipment, one thing that we do is really the fabrication of components and the advancement of manufacturing technology for the development and the production of components, looking at various aspects of digitalization and fabrication, using welding, additive manufacturing, surface and finishing, visual inspections, all kind of enabling technology to lead the development of new fabrication technology that are flexible, affordable, easy to operate, connected, and obviously sustainable. And one industrial R&D group that we have in that field is the Metalltech Industrial R&D Group, and basically that is committed to shape the future of manufacturing with a group of industrial partners. And the main goal is to increase speed and agility and adaptability of the manufacturing processes for metallic components. increase the sustainability of the processes. And really the benefit for the community of interest is to bridge the gap between early stage R&D to technology market readiness and decrease investment risk. Solve some of the industry-wide technology problem, increase cost effectiveness of emerging products, and create complex technology solution to address some of the industry needs. And we are acting in the pre-competitive area from TRL 1 to 4. And the idea is to bring a value chain together, a value chain that will work and collaborate in the future for the development of their own products. And for and all those elements that you see here, the benefits from this Metalltech group, are the ones that we're always using for the creation of our other industrial R&D group. We have 9 of those in operation, and I'll share one in a few minutes on the rail side. To close on this one, here an example of a current ecosystem for the Metalltech group. And you see that basically companies goes from the raw material supplier up to the final product vehicle assembly. So a company like Prevocar or Alstom are a member of that groups. And basically they're pulling on the rest of the supply chain and gaining access to new manufacturing technology, to new material, to new assembling technology for their products, providing challenging manufacturing solution to address some of the needs of the end users. And basically, the one example of a project that such groups are advancing are incremental manufacturing platforms for structural aluminum. Basically, dedicated for a large component, the idea is to shape the component and add a stiffener to the component, so to have an integral part at the end, instead of using multi-part assembly, is try to advance on several elements of the manufacturing. Integrating 3D additive manufacturing to vision systems and to robotize machining, and the idea is to come to tailored topology for getting large structure with minimal warpage. Now, another set of program is around clean and energy efficient transportation. And on this one, really, we're looking at the enabling technology for electrification. And we are supporting the development and improve propulsion technology towards a zero emission future. And really, we're looking at things like aerodynamics, alternative fuel application, battery, electrical machine, fleet energy efficiency, and hydrogen application. And the type of work we're doing goes from technology watch, life cycle analysis, to prototyping of vehicle, testing and demonstration, as well as AI and data analytics. And one example of, sorry, I went in the wrong direction. An example is that we're involved into the electrification of GO train through Hydrail. Basically, the objective of the project is to analyze the benefit of electrifying GO train network via hydrogen and fuel cell, Hydrail, so versus catenary connection. And this is a multi-party. We're not leading the project, but basically we are collaborating and providing part of the solution or part of the understanding and knowledge around the regulatory framework, and reviewing the system packaging, system design, packaging integration, looking at the code and standard and the regulation and the H2 safety and ASA, to lead and working with the Canadian Nuclear Lab to provide some of those to the feasibility study. And the great thing about NRC is that we can pool the expertise across all the research centers of NRC. So the hydrogen capacity, the hydrogen's knowledge is not only residing into the automotive and surface transportation research center, it's also into the energy, mining, and environment. So we can go and interrogate and find the right expertise for the right subject. The same thing with code and standards, where we can turn back to the construction research center and start looking at more definitive codes and better understanding on the construction and infrastructure development, so that we can address all the aspects of deploying Hydrail for very specific applications. Another example is a trial ongoing right now at TTC on electric bus. And really there, the role of NRC is to work on, to develop and analyze the energy report, and integrate some machine learning development tool to analyze routes and ease the route analysis and the deployment strategies for new vehicles on complex transportation systems, and make and help end user to make the assessment of the technology and develop best practice documentation. Really, the objective of TTC is a transition to zero emission fleet with and they did the acquisition of 60 battery electric buses. And basically, NRC is do the examination of the performance of the battery electric buses over the course of the full program. And we are providing some of that knowledge. And where we pull our expertise is really across our data, our digital technology group on data analytics, also within our new group in Leicester, looking at advanced data analytics for transportation. Another example of program is our resilient ground transportation program, and I'll spend more time on this one. This is the one that is addressing most of the current needs and current challenges facing the railway industry. This program is really aimed at developing a more productive and connected and safe transportation system. And really the vision is seamless all-season ground transportation. So looking at the impact of climate changes, but also the impact of seasons on new technologies to be deployed in the country. And we're looking at rail for good transportation, rail for passenger transportation, transportation enabling technology, and advanced ground vehicle transportation. Today, I'll just focus on the rail ones to give you a bit more detail of the type of work we're doing. Some of you saw this morning some of the activities that our groups are doing, especially on the climate change side, looking at the railway infrastructure and the rail side and the grid. So one step of program, one portion of the program is the Rail for Good Transportation. And in there, we're looking at increase the safety of operational efficiency, improve braking performance in winter, optimize rail car design, reduce terrain forces and prevent train separation, and improve rail car resistance to our operational environment. And here one example. We're working with QNS NL, a short line operator, and looking at identify high forces location before they cause track geometry defects. So, and about 50% of the high forces curve identified by our instrumental wheel set were not included in QNSNL maintenance plan. So really, the difference here was to implement and deploy instrumental wheel set on their system, monitoring in real time what is going on, and provide track maintenance and field expertise knowledge, so to improve the efficiency of the system using remote health monitoring. So the facility that we use is coming from our Leicester group on instrumental wheel set. and over-the-road testing capability and instrumentation. That group also include the data analytic groups, looking at how to bring that data set together and make sure that we extract the real signal that we are looking for, and to provide certainly the best identification of the problematic region. So you saw some of the conclusion is that in their first pass, we were able to identify several I-force area where QNSNL can now deploy their maintenance plan. Another example is the cold weather air brake research facility, where we're looking at the safety and efficiency, which will have an impact on safety and efficiency in Canada. And basically, the air brake are known to have leakage, and the leakage increase in cold temperature causing the decrease of performance. The idea is that obviously we cannot do a full train testing. We want to control the environment as much as possible. So the idea came to develop a modular brake system that replicates several rail cars and install that modular system in our climatic chamber and replicate any train, any location in a train, and be able to control temperature between -40 and +50. And identify the weak points within the brake systems by simulating real train operation or profile, and access and manage the impact on in-train forces with our modeling capacity. And we have 3 collaborators on this one with Transport Canada, 2 collaborators right now, but this is an area where we want to expand collaboration, looking at other players and continue the deployment of the knowledge across several other operators. Right now, we're working with the Hudson Bay Rail, and we hope to publish the finding in the near future. Here another example of a collaborative research group, very close to what we call the industrial R&D groups. And basically, we're looking at wheel shedding issues, which is a significant issue in the rail industry, you know that. And it's really to improve the rail car resistance to harsh operational environment. Again, the expertise coming from our instrumentation and testing group, looking at the wheel and rail interface metallurgy and the and some aspect of modeling and simulation. The complex issues is there's no single cause, there's no single solution, and it's cost prohibitive for one single organization. This is why we started to build a partnership among several companies like TTX, Willet, and Runsco, QNSNL, VRL, to work on that problem and advance on what are the solutions that can put forward in the near future. And another subject in this area is the environmental durability expertise. We have a group in Saguenay, Quebec, looking at the corrosion of transportation equipment. Their expertise goes with the aggregating the data from real life experiments. So how they do it, they're creating all kind of structural assembly examples that they put under a truck, a delivery truck, going through various roads, various conditions, and they're monitoring live what are the conditions. So the humidity, dew points, temperature, salt content, and basically having access to the data and looking at corrosion currents, looking at some aspect of the electrochemistry of those various assembly live. So collecting a significant amount of data. And here, the idea is to model that, and that's what they created. They created a model to predict corrosion so that they can integrate that model into structural design software tools, so that they can optimize the assembly and the structural component to integrate the stresses and the impact of stresses on corrosion. And the software basically has been integrated into finite element analysis, corrosion apps that is calibrated within service exposure results and allowing simulation of galvanic corrosion, a variety of material combination. And the idea is really to improve the design, go to lightweight design, integration of new material, and making sure that you're not making errors and increase the durability of the overall equipment. Another set of example is around the rail for passenger transportation and looking at minimize environmental impact on operational safety, efficiency, safety, noise, and vibration for passenger communities. Increases safety in operation via in-service remote health monitoring, and initiate best practices for Canadian light rail. And finally, looking at optimized rail car ventilation and climate control for L2-year travel. And one example I think you saw, some of you may have seen this morning, was the effect of Freeze-Thaw cycle on safety of performance of railway track. So looking at various events and studying and looking at the higher track roughness in the spring, higher track softening, larger differential deformation, and more frequent, that leads to more frequent track maintenance. And really the objective of the goal is to minimize environmental impact on operational safety, efficiency and safety, through our group working on instrumentation, some of our experts in geotechnical and data analytics. Really the approach is to instrument a section of a track with several instrumentation to monitor track and subgrades performance under various climate conditions. The project is right now collecting data for more than 4 years and continuing in the future. And really the objective is to bring a greater understanding about the effect of freeze-thaw cycle on the integrity and safety of our railway tracks. Another example of instrumentation is the improvement of ride quality through in-service remote health monitoring. This is an 8-month in-service data collection project that identify poor ride quality sites to improve the track and the maintenance of the track. Target to get to target maintenance and track on several track issues, and really it's to assist VRL in planning maintenance for fall and summer. And again, this is looking and working with our instrumentation testing group, again the geotechnical group and vehicle simulation and data analytics. And really the objective is to improve the comfort and you know the travel over VRL systems through very specific track maintenance area and to reduce costs or make cost-effective maintenance decisions when it comes to improve ridership. Another example is a project with New York City Transit, where we were again using the instrumented wheel set that we developed and used to enhance operational safety, enhance system resiliency, reduce energy use, in particular in some area of the system of their system, and reduce the planned capital costs. And overall reduce the cost of asset ownership, and finally improve the customer service and customer experience. In this case, this is a long-standing project with New York City Transit, Pacer, University of Delaware, and a couple of other players. Really, it's a broad expertise around vision system, track geometry measurement, transit with the transit operator. We have expertise coming from various segments of these partners. And really, again, it's working with our instrumental wheel set in service demonstration evaluation of instrumentation. Oops. Another example is automated safety inspection of a system for railway switch. So again, here is integration of instrumentation on vehicle, and it's really to work with laser-based track inspection dashboard, and passenger railway operator. And it's again with VRL, Pavematrix, and CEGEP de Sept-Îles. And the idea is to do in-service demonstration and evaluation of technology. And it's to develop a demo of automated safety inspection system for railway switches with an AI-based algorithm and GUI software. In collaboration through funding is coming from TC Rail Safety Improvement Program. Again, another set of project is around the level of water near railway. Again, here addressing some of the future challenge related to climate change. This is a joint project with Ontario Northland, VRL, McGill, Transport Canada, and NRC. And it's really to use both UAV and satellite technology to offer inexpensive and effective method to detect water near railway. The initial work is really around gathering the data, developing analytical tools to identify when we have water, where the water is compared to the reference, and is to provide a greater understanding about the potential of remote sensing technology for detecting, monitoring water bodies on railway tracks. And another area is the development of guidance and best practices for Canadian passenger rail car. In this case, is really to identify gaps between the industry environmental challenges and the rules that guide the industry, provide recommendation filling these gaps, and provide recommendation for future project and works to address environmental challenge faced by Canadian passenger rail systems. And in here, it's really our goal is to review some of our the best practices and provide guidance to the operators. And finally, the last set of project is around transportation enabling technology, looking at rail derailment impact map and analytics, and develop risk mapping. And in here, one key project is really to develop an interactive risk mapping and assessment for trail derailment impact. And it's really around looking at the network, looking at the probability of incident and the consequences, and develop a risk map. And where we want to go with that is really develop risk mapping capacity and knowledge. And it's really linked to the available data, but eventually integrating also other factors like population and environmental, so the weather area, the risk of wildfire, for example, and other risks that could increase the potentiality of the risk and also the impact of such events. So, to conclude, how can we advance on some of those projects? How to engage NRC and the automotive and surface transportation research and testing? Really, we want to be a single point of contact to connect the right expertise within NRC. Like I said, we have several expertise across the board, going from construction and infrastructure to energy, mine and environment to building and manufacturing rail vehicle to the operation of the system. We want to bring the right stakeholders around the table and build value chain group of people that can bring technology together and an operation for an efficient transportation system in Canada. And we developed throughout the years many ways to structure the work into the terms of our partnerships. Can go from, like I said, industrial R&D group, where it's more like a group of people sharing with membership, sharing part of the cost of the investment, and NRC looking to increase that investment through other collaboration with funding organization. And at the end, NRC, working with partnership with academia, will lead and execute some of those projects with our leading expertise and facilities, and really drive to your project success. So on that, I think that concludes my presentation. So thank you all, and I think we have some time for questions.
Yes, thanks so much for that talk, Eric. We have about 15 minutes for questions here. I just wanted to know that it's nice to kind of get to see the big picture, what the NRC is doing. I think most of us kind of tend to see what's happening in our little specific niche worlds. So it's always nice to see the big picture. And I know we have a couple more presentations from NRC people today and tomorrow that are going to be providing us with more information on the great work that's being done there. So we got our first question here. So thank you for your first presentation, Dr. Baril. You mentioned that AI predictive maintenance was disruptive to operations. Can you elaborate on this?
Yeah, that's a very good question. Is that obviously data is always available, and there's a lot of data available, and crossing data together is always where we start generating value. The example of that is when you start looking at the risk mapping. Risk mapping, you can look at only one factor of risk, which would be the quality of the rail. But you could look also at seasonal events that will create even more disruptive event for the rail operation that will increase the risk. And to identify in which scenario it become very important, AI has a role to play, because you have among this a lot of data to handle, and to find very critical set of data that will have an impact. AI is useful for that. And certainly disruptive in the sense that we can use those pool of data and start getting more value out of the data sets that we have.
Perfect, thank you. We have another question from Chris Bunce. Great presentation. What satellites and technologies are being used for monitoring water levels near railway tracks? Can you provide a reference to publications on this research, perhaps?
Yeah, that's a very good question. I may go back to, I invited Albert Wada around the table. Albert can provide maybe a little bit more guidance, or at least certainly refer you to someone that can help with that question. Albert.
Thank Chris for the question. I'm going to put my email address on the chat box, and I'd be more than happy to provide you some publications that already published in the public domain, so you can see some more details about the project.
All right, we have another one from Caroline Healy. So Dr. Baril, how does NRC interact with TC Innovation Center?
It's a good question. Actually, we have various. Actually, we are working together on various projects, looking and advancing some of those projects, and often we are partners on some of those projects, or we are contractor. It depends on the outcome of the desired outcome of the project. But we do have a relationship with the Transportation Innovation Center.
Thanks. Next question comes from Lucas Aronson. Are you including climate change resilience or changes in hazards in response to climate change into your risk assessments?
That's a very good question, and you're reading the future. This is where we would like to go, is be more predictive and integrate scenarios on some of the risks. And this is the direction that we're looking for the future research. But now it's more really about the data and historical data, and trending on and look at the trend on those historical data. Thanks.
Next question comes from Gord Lovegrove. So his question relates to the NRC research motivation. You noted it is all about efficiency and economic drivers, but I see a lot of overlap with environmental impacts, which of course have economic impacts if not dealt with properly. But do you foresee a more explicit environmental mandate coming, specifically the need to meet climate change targets?
That's a great question, and the answer today is yes. In collaboration with the other partners that we have, ECCC, Natural Resource Canada, Transport Canada are key players on that direction for climate adaptation and also mitigation. And both fronts are looked at. We discussed about, I presented one project or two projects on what we do on greenhouse gas emission reduction or enabling greenhouse gas reduction through electrification of transport. That's one example on that side, contributing to the reduction of emissions towards the targets. How can we be more explicit? NRC is the tier 1 of research of the federal family. So we're there to provide the knowledge and helping the policy development from the various departments in their line of sight. So the answer is yes, but in collaboration with our colleagues from other departments.
Thanks. The next question actually comes from me. I'm curious about, you mentioned using technology to overcome the challenges with seasonal changes. So I'm curious if there's a specific technology you could talk about that you might be employing to overcome, say, like spring runoff or things like that, which is a very difficult time for the railway network.
It's a good question, and this time I'll rely to Albert on that specific question, if they explore some mitigation strategies around some of the early findings that we have on that project.
Yes, Kevin, understood your question correctly. You're talking about some of the technologies for dealing with climate change. Is this your question?
More so dealing with seasonal changes. So when we go from, let's say, winter to summer, there's the spring runoff that happens that really affects railway industry. So I'm just curious if you guys have developed technology to monitor or to help kind of mediate that challenging time.
Yeah, the program just is, initiated or launched last April. So we are at the stage of collecting information now. So one of the projects we talked about is the freeze-thaw cycles and see how this impact the railway infrastructure. Moving forward, we'll be looking at, okay, what mitigation measures can be taken, and then try to go to the next phase of trying to implement them in the field and see how they can perform in real life as a mitigation measures. So it's unfolding as we go. So we're at the stage of collecting information now for this one.
Thank you.
We're also open for other ideas. The railway industry is around the screen. So if you have any specific challenges that you are facing, we are here. We can, again, it's just starting, so we can add more projects to our list.
Sounds good. Our next question comes from Gord Lovegrove again. Can you speak to any research on rail across permafrost areas, especially as it relates to climate change and building new corridors to remote communities?
That's a great question. And I do know that we have a couple of projects with our construction group on the infrastructure side, and maybe Albert, you can comment on that one. I'm not aware on the specific of those projects yet.
Yeah, we started with phase 1 of the project, which is doing a gap analysis on this field. So this was just completed a couple of months ago. And, I think the results from this one can be in public domain. So in the future will be presentations coming out about that. And following phases, again, we'll be looking at how we can use this knowledge and how we can fill some of these gaps.
Perfect. Seems that you guys have satiated everyone's thirst for knowledge on NRC today. I don't see any more questions. We can give it another minute if anyone has one, but thank you so much for that presentation. So yeah, thank you again, Dr. Baril, for your informative talk, highlighting the current work from NRC. We're now actually going to take a brief break before we reconvene at 1:40 for our next technical session on cold regions engineering.
Great, thank you. Thank you for the opportunity to present the NRC's work.
Well, I think there's a couple more questions if you're still willing to stick around.
Yes, we are.
Okay. Chris Bunce came back with another question here. Given the Transport Canada requirement for risk assessment on dangerous good routes, what is the need for real-time or periodic updating of risk mapping and assessments? For example, the summer 2021 increase in the frequency of debris flows following the wildfires in British Columbia may have changed the risk of transporting goods on some routes. Will the interactive risk mapping and assessment you discussed consider this change for the Canadian rail industry, or will the individual railways be responsible for the assessments?
That's a great question. I don't know if we have all the answer to that question, all the angle of that question, but I'll let Albert to come with at least an initial answer.
Yeah, it's a very complex one. We don't set policies, so I don't know how to be implemented, who will be responsible for what. As Eric mentioned, we are the science convener. You know, we're trying to bring knowledge to the industry, or trying to bring the facts and some tools to allow us to monitor and predict some of these risks. But we'll leave it to the industry and the regulators to figure out ways of implementing it.
Perfect. Thank you, guys. I think that might have been the last one. So we're going to take that break now that we mentioned. So everyone will be back at 11:40 for the next round of presentations. Thank you so much, Dr. Baril and Albert.
Great. Thank you, Calvin.